All right, it's recording. Here we go. HEH, probability is a short chapter, 4 exercises, but really you can do it in 2 sessions. So the first session we're doing HE8H. Let's have a look. Shh. Thanks, team. Yeah, Ashwin. Thank you. Maybe I'll just wait till Ashwin's ready. All right, we're ready. Let's go. Sample space. So a couple of terminologies we need to go through. Sample space. When we say sample space, it actually means it is the set of all possible, and now the proper term is outcomes, but really they mean results of an experiment. Now an experiment sounds really fancy. All it is when we say an experiment is anything that has a chance. Anything that has a chance that can occur out of it is called an experiment. So, what's an example of a sample space? Here we go. If I'm rolling a dice, right, a regular dice, 6-sided dice. If I roll a dice, the possible outcomes I can get or the results I can get are 1, 2, 3, 4, 5, or 6. So when you answer the question, if they ask, what is the sample space? This is how I want you to write it. You will write sample space, but if you're game enough, there is a symbol for it. Instead of writing sample space, it's the epsilon symbol, okay? Or if you wanted to make it easier, you can do that symbol, okay? So those 2 symbols usually represent the universal set, but I'll do that universal set again, okay? That epsilon E is the universal set, and it just means sample space. So I want you to write either sample space or the symbol, or you can do this E. You'll see it in your textbook as well. And then I want you to write equals, and notice this bracket I'm drawing. It's not an open bracket, it's not a closed bracket. This is called a curly bracket. Proper name is braces, okay? Now, you only use braces or curly brackets when you're listing items. So in our case, we will list the options for the sample spaces 1, 2, 3, 4, 5, and 6. And yes, you do have to put the comma because later on when you're doing probability, not all things are numbers. Sometimes it could be a chair, table, or it could be a name of a brand. And because of that, if you don't put a comma, people don't know where it separates. They don't know if it's 2 words or 1 word. The comma tells people that's 1 item. Okay? So that's the sample space of rolling a dice because it's all the possible outcomes you can get when you roll a dice. Let's do another example. What if I had a spinner and it was broken up into how many? Let's do 6. 2, 3, 4, 5. 6. What's my sample space? Yeah, very good. So I was trying to trick you with a spinner, same idea. If I spun this wheel and I asked, what are the possible numbers that can come up on these wheels? Well, my sample space again, curly brackets, 1, 2, 3, 4, 5, and 6. What about something that you're more likely to get? Flipping a coin. What's the sample space of flipping a coin? Can I please have Liam? Heads and tails. Very good. You can do H or T, or you can write heads and tails or comma tails, right? So sample space, you can write it like that. Your textbooks will likely not use the symbol as the part of the answers. They'll write sample space, but you can use the symbol, and you'll notice they use the symbol here and there too. Okay, so that's the first term. Sample space just means what is the total possible outcomes. Now, complement is tricky. Tricky to first understand, but once we do a couple of examples, you'll get used to it. Now, a complement is often used with a dash on a capital letter. So in this case, complement of E is written as E dash. If I say complement of A, you would say A dash. If I say complement of B, you would say B dash, right? So what does the dash mean and what's the complement? The complement means that that group, so group E or group A or group B, has all the outcomes, okay, that is not, now fill this in, not part of that group. So I know that sounds very confusing, so let's make an example for you to understand. Rolling a dice. You told me the sample space was 1, 2, 3, 4, 5, or 6. True? So that's all the possible options they can have. But grouping, I can say the group A has the numbers that are even. So there could be 2, 4, and 6. I could say group B has all the odd numbers, 1, 3, and 5. I could say group C is the numbers of 3 and 5. You can make up any group. Notice that we use capital letters for those groups. Yeah, because we can't be bothered writing 2, 4, 6, 1, 3, 5, 3, 5 every time. So we use the letters to represent those groups. Now, if I said complement, a complement means that in this group, it has all the outcomes that A doesn't have. Well, I just want to know what goes into a complement first. So if group A has 2, 4, and 6, then what would a complement have? 1, 1, 3, 5, because that's what's missing. Because a complement means I have all the items that group A doesn't have. Okay, so let's do another one. What about B? What's B complement equal to then? 2, 4, 6, because it's everything that B doesn't have. What about C complement then? Good. So it's got everything except 3 and 5. So it should have 1, 2, 4, and 6. Does that make sense when we say complement now? So we're saying it is the group that is not a part of whatever group that you're looking at. Okay. What's interesting is if you combine A dash and A, so A complement and A, B complement B, and C complement C, you get everything. Okay, it should be everything. It's like the opposite of each other. Yeah? So here, what would be the complement? As the example, what's the complement of rolling the number 3? Yes, Sally. Very good. It's everything but a 3. So if you're rolling a dice, you can. There's only 6 options. Then you can get 1, 2, 4, 5, or 6. That's what the complement of getting a 3 is. Okay, so that one's tricky to remember. I often still teach my year 11s when they first come back into probability. I have to revise them with that again. Experiment, like I said, it is just what leads to a chance. So anything that has a chance is an experiment. But experiment is different to trial. So let's say flipping a coin is the experiment. So this is called an experiment. Flipping a coin is experiment. But how many times you flip the coin is the trial. So I can flip it once, that's trial 1. I can flip it twice, that's trial 2. I can flip it 3 times, that's trial 3. Same thing with rolling a dice. Rolling a dice is the experiment. But then, how many times I roll it? Roll it once is a trial. Roll it twice is a trial. Does that make sense? Okay, now, when we say probability, as mathematicians, we're really lazy. It is a chance of an event occurring. Now, what is an event? For those who don't know, it's those capital letters I just used. It's a group. So think of it as groups. So when we say the chance of a group occurring, what are you looking for? You're looking for the chance of getting odd numbers, chance of getting even numbers when you roll a dice, or is it the chance of getting a 3 when you roll a dice? Whatever that chance of is, that's called an event. Every time you do an experiment and a trial, there's something you're looking for. We call that an event. Now, as a language, it's really painful to try to write this every time. When rolling a dice, the chance of rolling a 2, that right there, takes too long. So as mathematicians, we use a symbol to represent that. When you write capital PR, it has to be capital P, that means the chances of. That's what it means, the probability of getting. The probability of getting something, yeah? So this means here, probability of getting. The event is what you're focused on. Now the event, you can use a letter to represent what it is that you want. So in my case before, if you notice, I used A as all the even numbers, B was all the odd numbers. Then instead of saying probability of getting odd numbers, I could have just wrote probability of B. Because that would mean the same thing. But that means that I need to know B is getting odd numbers. That's what the event is. So you'll find that in your textbooks, they might not use the symbols I'm showing you, but they will use this one. They use PR, and then inside it, they do a description. Later on, when you get to year 11 and 12, we're too lazy to write the description. So we start to define them. We use letters to represent that. Okay? So I'm going to teach you how to use those letters and get more familiar with your answers and how you write them. Okay? Here we go. So that's the notes for today. The sample space, complement, and then how to write probability. Three notes. Okay? Let's do an example. Let's do a simple one, flipping a coin. So flipping a coin, that's my experiment. When I flip a coin for the first trial, I can get possible answers. The sample space tells me all the possible answers. Now, I think it was Sully before, or Liam. What was the sample space of flipping a coin? Heads or tails. So you say heads, comma, tails. Make sure to use the curly brackets. Make sure that when you're writing your answers in your exercise book to write sample space or the symbol and then an equal signs. I got my sample space. I can either get heads or tails. Then they say probability of flipping tails. Now that's too long to write. As mathematicians, we're lazy. So instead of writing probability of flipping tails, you write, very good, PR of getting T. That there will tell people that you're looking for the chances of getting tails without actually writing probability of getting tails. That's what that means. Now to work out the probability, you look at the total sample space. How many options can you get when you flip a coin? There's only 2. There's either heads or tails. So you're out of 2. You're looking for one particular thing. The event you're looking for is tails. That's the event. So how many tails are there? There's only 1. That's why you say you got a 1 in 2 chance of getting a tails when you flip a coin. Or you can say 50% chance because you've learned how to convert fractions to percentages now. Okay? Then what about the probability of rolling the complement of getting tails? How would you write that? So we're too lazy to write probability of rolling the complement of getting tails. That sounds too complicated. How do I write it more succinctly? Beautiful. I love the fact that you said brackets. A lot of students skip this. You can see my year 11 students, if I open up their book, you'll see the students who aren't careful with their notations are often the students who struggle with maths. They will not have the brackets, okay? Because the brackets, most students don't know how to use. The brackets is key because it tells you what the event is. So PR is the chances, T is getting tails, complement is the dash. What would the answer be then? 1 and 2, because if your complement of getting tails means not getting tails, which is getting heads. So chances of getting heads is out of 2. There's only 1, so it's still 1 out of 2. So far, so good. So I'm teaching you how to use the notations here. Let's try the next one. Here's the first example. We've got 2 examples to do today. Here's your first one. Let's say the word print was written on 6 different cards. Okay, so you got card number 1, card number 2, card number 3, 4, 5, and 6. They have those letters, P-R-I-N-C-E. If I told you that I'm going to choose one at random, I'm going to close my eyes, I'm going to pick a card, right? Then the first thing I need to figure out is what are the possible options I can pick? That's my sample space. So again, sample space equals, what's my sample space equal to? Good. Make sure to put in the commas, I-N-C-E, close the curly brackets. That is my sample space. So I've got 6 possible options. First question says PR, the letter N is chosen. What that's saying is, what's the probability that if I close my eyes and I chose a card, that it's going to be N that's been chosen? What's the chances? Now to work out the chances, how many options do you have again? 6. So out of 6 options, how many of the event I'm looking for is the letter N? There's only one letter N. So hence it's 1 out of 6. But I don't want you to just write equals 1 out of 6. I want you to get practicing to use the notation. So you would do PR of N. It's equal 1 and 6. That's what I want to see in your exercise books. I don't just want to see 1, 6. I want to see that PR notation. Let's try the next one. Notice that they defined a variable. They said let V equal the chances of getting a vowel. Now let's remind ourselves, for those students who aren't familiar, what is the vowel? Well, what are vowels? That's right. A, E, I, O, and U are vowels. What's the opposite of vowels? Good. Consonants is the opposite of that. So essentially V dash is consonants, whereas V is the vowels. Now, if you have a think about it, in the word prince or P-R-I-N-C-E, how many vowels are there? 2. There's I, there's E. So when I say, what's the probability of getting a vowel? It's out of 6 again, but you only have 2. In year 11, I would penalize you if you left your answers to 6. What should the answer be? 1 over 3. At year 11 and 12, examiners penalize you because they assume you don't know how to simplify fractions. By that point, they assume everyone knows how to do it. So if you leave your answers to 6, you lose a mark. Okay, so you must simplify your fractions to simplest form. And the next one is? Very good. Which we already know, if this is 1/3, the leftover must be 2/3. But if you didn't know that, you can count how many not vowel letters are there. There's 1, 2, 3, 4. That's why I know it's 4 out of 6 or 2 out of 3. But later on in my year 11 and 12s, they do need to understand these two are opposites of one another. So if you know that's 1/3, the other one must be the leftovers. So if it was 1/5, then this is 4/5. If that's 2 sevens, then this is 5 sevens. Okay? There's that relationship between complement and the actual set or the event. So far, so good. Example 1, pretty good. All right, so that's the first exercise. That's 8G. Now, if you flip over, I've now made the problem a bit harder. If you flip over, how did I make the problem harder? There are 2 steps. So instead of just picking a card, this is where if I asked you, what's the probability of you choosing a number 2, well, actually, let's say an odd number, and an H, or S, or A, is an example. This one, if I ask students right now, if you had to spin the spinner, there's going to be a number that pops up, and you have to randomly pick a card. What's the chances of you getting an odd and an A? And that's a bit harder than just saying, what if I just picked an A? Because if I just picked an A, you would have said it's 1 out of 4. If I said, what's the chances of picking an odd number? You would have said 2 out of 3. But now I'm mixing 2 things together. You can still do this intuitively, but we want to teach you a technique that helps you to problem solve methodically. What's the method? It's an introduction of what we call a two-way table. And the two-way table is used because you got 2 things happening. this is how it works. Here's your two-way table, right? Now, on a logical sense, if you did this intuitively, if you spun the wheel, what's all the possible options you can get? 1, 2, and 3. So you can get 1, 2, 3. But then when you choose a letter, what are all the possible letters can you get? Yeah, so you can get A, T, H, and S. But that means, if you think about it intuitively, you could get 1A, 1T, 1 and a H, 1 and an S. Because you could spin it and get a 1, and you happen to choose an A, or you can spin it and get a 1 and get a T. So if you filled it out, you got 2, you could get 2A, 2T, 2 and a H, 2 and an S, or 3 and an A. How many possible outcomes would there be? 12. So you could have done it intuitively. You could have sort of figured it out intuitively and get to that point as well. But the two-way table helps to visualize what I just wrote here, that you can either get options for the first one, 1, 2, or 3, A, T, H, and S, and you can see that it fills out nicely. You get 1A, 1T, 1H, 1S, 2A, 2T, 2H, 2S, 3A, 3T, 3H, and 3S. So it makes sense that you can get a 3 on the spinner and then chose an A. Or you can get a 3 and a T. Together, that's 3 by 4. That's why we know there are 12 possible outcomes. So with the diagram, it makes it easier for you to say what the sample space is. The sample space is clearly, you don't have to write this again, I'm just spelling it out for you. Yeah, so it's 1A, 1H, 1T, 1S, and then 2A, 2T, 2H, 2S, and then 3A, 3H, 3T, 3S. Get me? Okay, and that's how you know there's a total of 12 outcomes. The diagram just helps. It's a tool that not all students use, but it's just good when you get a problem that you know there's 2 possible things happening. Yeah? Now that you know the total, it's much easier to solve for the probability. Let's do the probability now. First one. Find the probability of spinning a 2 and choosing the letter S. So I'm saying PR of 2S. We know it's out of 12 because we've done the table and we can clearly see there's only 12 possibilities that could occur. Out of 12, how many have a 2 and an S? There's only 1. Clearly right there. You can only get a 2 if you happen to spin a 2 and then choose an S. There's only one way of doing it. So the chances must be 1 out of 12. See, initially when I first asked, some of us might have known how to do it. Some of us might have figured it out eventually. But this is teaching you a method to get there. But the next one gets you to think about it. Had you not had the table or you didn't list out the options, it might make it a bit harder. Let's answer the last one. What's the chances of spinning to get an odd number, kind of similar to the one I asked before, and then getting an S? So again, you got 12 possibilities. How many is odd and also H? So this is H. Which ones? Very good. So to get H's, there's only 3 options you can get H's. But out of those 3, you can get either a 1H and a 3H there. So the probability is 2 out of 6. But again, you don't leave your answers 2 out of 12. It must be 1 out of 6. You've got to reduce it to simplest form. This is exercise 8H. So 8G was 1 event or 1 experiment. And then 8H is 2 experiments. So I'm combining them 2 together because there's a lot more going on in H, but you choose where you want to work. And you want to learn a couple of things: sample space, probability, complement, and how to write the notation. Okay? That's your session now. You got about 24 minutes of your time. I'm going to stop the video.